Work check done. You can turn that in today. And I can even give it back to you tomorrow so that you could have it to study. The homework check only went through yesterday's assignment. What we are talking about today, one tiny piece of it is on tomorrow's quiz, but the rest of it's not. So I'll specify as we go through the lesson, okay? So this is just something that is on the quiz. Little warm up. How do we find f of -2 using this graph? Okay, we go to x equals -2, which would, according to this, be here, right? Because they're counting by twos. And what y value do we get? Also -2. All right, f of -6 would be x equals -6. Yeah, it's open circle. No, I think it's undefined there at -6. Do you see it doesn't even hit -6? So I wouldn't ask you that on the quiz probably, but it's undefined. F of 0. This is the one everybody messes up because they want to tell me it's like 5.9 or something over here. But f of 0 means when x equals 0, which is the y-axis. Is this thing ever crossing the y-axis? So this is also undefined for this particular graph. Now, does anyone know what this is actually saying? It says when f of x equals 2. What does f of x mean? Yeah, when y is 2. So that would be y equals 2. What x value is happening right then? 6. And if f of x is -6, which means y is -6, there'd actually be, that's the worst line ever, but there'd be two values, right? Over here at -5, maybe? Don't forget negatives. That's a silly way to get these wrong. And then it hits -6 over here around, what do you call that, 7 maybe? Okay, those are estimating, and they are estimating on the quiz as well, okay? All right, today on worksheet 4, we're going to talk about continuity, which is the concept that's sort of on the quiz, okay? We're going to talk about end behavior, which is all that approaches infinity, negative infinity fun. And we're going to talk a little bit about limits, but limits are honestly, I'm going to leave most of that until the very end of the year this year, that we have much conversation about limits, because that's the first thing you do in calculus. All right, a function is said to be continuous at a value if it satisfies all the following conditions, okay? If it is defined at f of x, okay, it's defined at whatever that value is, if it exists, and it approaches the same value to the left and right of that value. All right, it has to approach, that's a big old crazy definition that actually has to do with a limit, but this makes more sense to most of us. The graph of a continuous function has no breaks, holes, or gaps. Does that seem pretty clear? Okay. You can trace the graph without lifting your pencil. One condition for a function to be continuous at a particular value, okay, is that it approaches the same from the left and right, and that it exists at that value. We deal with this a lot, again, with limits later in the year. Thank you. Yes, Cameron. It says functions are not continuous, then they are discontinuous, and there's 3 different ways they can be discontinuous. They can have an infinite discontinuity, it's called, which would be like a vertical asymptote somewhere. So an example of that might be x plus 5 over x minus 3. It can't be 3, so it has a vertical asymptote. Remember things like that? It can have a jump discontinuity, it's called, where the graph jumps values. This happens mostly when we have a piecewise definition. So everything to the left of C was defined this way, everything to the right of C is defined this way, so at C it jumps because the rule changed at whatever C was. And when you have a removable discontinuity, it's called, we call it a hole. That was when, I don't know if you remember this, but you had like x plus 2, x plus 4 over x plus 2. Remember you had a common factor top and bottom? Okay, I did a really bad job because this would obviously be at a positive value, so it would be like x minus 2 and x minus 2 or something, okay? But when you had a common factor top and bottom, that's when we wound up with a hole. All right, now that we've discussed all three of those, I'm going to tell you that at no point am I going to ask you what kind of discontinuity it has, okay? I'm just going to ask you, is it continuous? Now, with that in mind, determine whether each function is continuous, and then it wants to know what kind it would be. But 2 absolute value of x plus 3. Can you guys know what that looks like? Yeah, it's a v, right? Remember that? Anybody remember that? Is there a rule on what I can put in here? You can put any kind of number into an absolute value, okay? So the question is, does it exist at 2? Well, if I put a 2 in, I get out 7. And it wants to know, is it close to 7 when you put in a slightly smaller or slightly bigger number? Well, guys, I don't want to spend a lot of time on this because we know it's continuous, right? You can trace that v with your pencil without lifting your pencil up. So yes, it's continuous. There'll be somewhere we're not sure, but I don't want to spend a lot of time on one where we are sure. Now, this is one that has some holes and gaps and asymptotes and stuff because it has a denominator. Can you tell whether it's continuous at 1? Well, the first way to tell is to put a 1 in and see if it's even defined there. If I put a 1 in, 2 times 1 over 1 squared minus 1, I get 2 over 0. So right away, I don't know what kind of discontinuity it has, but it is definitely discontinuous there because it doesn't exist. Okay, I can't put a 1 in. X cannot equal 1. So it is discontinuous. And that's all I'm going to ask you on the quiz is yes or no. Okay, I'm not going to ask you, is it a jump or a removable discontinuity? Okay, if we factored this, I think it would be a vertical asymptote. Does anybody remember what that one is? Yeah, it is the infinite one. Good call. So it would have been infinite, but I'm not going to ask you that. Okay. This is the one that can have a jump. It doesn't always. But what happens at 2 is it changes rules. Does everybody see that? So up until 2, it was this rule, and at 2, it was this rule and beyond. So our question is, when we put a 2 in this rule, do we get out the same thing as this rule? In other words, do they meet up? And we're going to be graphing these in just a couple days. And then we will spend more time worrying about whether they actually meet up. But if I put a 2 in the top rule, what do I get out? 5? Now, that on the graph would be an open circle because it can't actually equal 2. Say it just says greater than 2. If I put a 2 in the bottom rule, I get 2 minus 1, which would be 1. And that would be a solid circle on the graph because it's the or equal to 2. Do you remember doing these a little bit before? Okay. But my question is it the same? Do they meet up? No, it jumps, right? So this one is not continuous. Or discontinuous is the word. We did not put a piecewise one on this quiz. And students struggle with this. Why did you put a 2 in here, Hofbauer? Well, when you graph it, you have to go right up to the 2, right? And that's where the open circle goes. So we went ahead and put the 2 in and find out there'd be an open circle at 2, 5. But then when it switches rules, it jumps down to 2, 1. By the way, if we had graphed this one, okay, it would have been doing something like this. And then over here, doing something like this. Okay, we're going to get to graphing those. but there is a jump, and that jump occurs at 2. By the way, everywhere else, this is continuous. The only place it has a discontinuity was 2. All right, what about this one? Can you picture that graph in your head? What is this? Just a parabola, right? So is it discontinuous anywhere? No, it's continuous. If we put a 4 in, we get out a value, but all we really need to know is, yes, it's continuous. Oh my goodness, I can't even write that. Yes, continuous, because it's a parabola, okay? I don't care about what value you get out at 4. You'll get one. All right. The next section is on approximating zeros, and this is an old school by hand kind of thing, or it can be a calculator thing to look for hidden behavior. If you put in an equation like this, x cubed minus 4x plus 2, the directions say determine between which integers the real zeros of this function are located, and it gave us an interval from -4 to 4. So I would have put this in my calculator and my y equals, and we'll do this with one in a second. And then I would have looked at the table. Okay? Now, what this theorem or postulate or idea is asking us is, from -4 to -3, the graph was negative the whole time. The y values stayed negative. Do you see that? From -3 to -2, though, the y value changed from negative to positive. That means somewhere in there it crossed the x-axis. Do you understand what I'm thinking about here on the graph? Then from -2 to -1, the y value stayed positive. It stayed above. From -1 to 0, it stayed above. From 0 to 1, it went from positive to negative. So somewhere in there had to be a 0. From 1 to 2, for x, the y value changed sign. So somewhere in there, it crossed again. Now, this is not foolproof, okay, because it could cross in between 3 and 4. It could cross and come back up, and we wouldn't know. They both would be positive. But it is an idea. It's called using a sign chart. Well, now that I showed you that, we're just going to use the graph and find the zeros, okay? We know how to do this. So I'm not going to spend time practicing that one. I want to talk about end behavior first, and then we'll do some graph analysis. Okay, I need everybody's focus because this is notoriously bad for students. I don't get it. But if I have this coordinate plane, when I say to the right, is that an x or y kind of a number? X. So going off to the right forever would mean x would be approaching positive infinity. Okay? If I want to do this, up, what is up? Up is a y, and if it was going up forever, y would be approaching positive infinity, or we will write f of x because we're just fancy like that. Okay? What if I said left? Left is back to being an x, and left would be negative infinity, right? And then down would be y, or f of x is approaching negative infinity. Now you can all tell me those things, but then we go to do end behavior and it gets real crazy. So one more time. When we talk about right end behavior, we're talking about what is happening as x approaches infinity. And there are two options. It can go up, which would be y approaching infinity, or down, which would be y approaching negative infinity. If we're going left end behavior, this one is doing what? On the left end of this graph, yes, on the left end, we'd say the function is going up as x goes to the left. Do you remember doing this last year? Okay. The book is going to write it in limit notation. We are not. We're going to use f of x. But I have to tell you, I messed up on the worksheet. I did not reprint it. We used to do x first because it makes sense for most students to say as you go to the left or as you go to the right. But unfortunately, that's not how they do it in calculus. So we're going to do it in this order. As long as you know what x and y are, it shouldn't matter. Do you have this at the bottom or somewhere on bottom of 4a? Thank you. So on 4a, it says the left end behavior means as x becomes more and more negative. So we will write this, x approaches negative infinity, and then we're going to fill in the blank here. Is the y going up or down? Okay. Right end behavior is x approaches positive infinity, and then we're going to fill in what's y doing, up or down. So if I were doing this graph, on the left and right, it's both going up, right? So we'd say as x approaches negative infinity, y approaches infinity. As x approaches positive infinity, y approaches infinity. But we're going to have to check that against our graph. It's not all the time. Okay, the y value, the f of x, may also approach 0 or any other number. If a graph is doing this and it stays at the x-axis, it never crosses, okay, then we can say as x approaches the far right, the function is approaching or staying at 0. So it doesn't have to be an infinity. All right, we're going to do this one. You have this one? I think your worksheet is backwards again. So why don't you just cross out what you have and write this? As in, I want to say the y first, because that's the way it's going to be on the quiz. I think yours says as x approaches, y approaches. Okay, so cross that out and write it this way, because this is the way it's going to be on the quiz. So, I still have to talk about x first. It just bothers me. So what do you want to do first, left or right? Okay, if we do the right, that's an x value is infinity. So as this graph goes off to the right, what are you going to tell me? The y is going up. So y is positive infinity. Okay, what's the second part? I already did x right, so now I have to do x left, which is negative infinity. The x's always have to be different signs. The y's can be the same sign if the graph is going both ends up or something. What is this one doing as we go left? It's going down, so the y, or f of x, is going towards negative infinity. So when I read this, it should be left end down, right end up. Cameron, you good? You doing these notes? Got this? Okay. So who can tell me this one? F of x approaches as x approaches. Okay. If I write that, what does that mean? As I go to the right, it's going down. So how do I write that one? Yep. That one means the left end is also going down. I don't have any requirement on whether you do left or right first. I don't care. Everybody good? Okay. Use the graph of the function to describe its end behavior. All right. I want us to type this in our calculator. F of x over x minus 2. What do we have to be careful of when we put that in? Whenever you have a fraction, yeah, I'm going to put the whole top and the whole bottom in. You don't actually need the parentheses around the top. But f of x divided by, you have to have the fraction around the bottom, x minus 2. Okay. Now we want to look specifically at some values. Okay? But we want to look at values that we type in. We don't want to have to scroll around in the table. Is everybody ready to teach you something new? Aislinn? Aislinn! We're learning something new on the calculator. Put this equation in, and then if you go second window, we don't want it to generate a whole table of values for us. We are going to type in the X value we want. So go down to this, and I want it to give me the ability to ask me for a independent variable, and then I want it to automatically generate the Y that goes with that. So we're going to put it on Ask Auto. So now when you go to table, second graph, you might have something in there, but likely it's blank. Okay? Now we're going to plug in values, and it's going to put in our X value into that equation and come up with a Y value. Whatever equation we typed in, Y equals. So, how do you want to check a value off to the far left? What would be a value off to the far left? Negative 60. Okay, I got 4.83. What's even further to the left? Yeah, you're like me. Negative 1,000 would be good, but I have this thing that I like type in like a bunch of nines, so I just put something like that. It's only one unit. What happens as we get further and further to the left? It appears this is approaching 5. Okay. How do we check on the right? What are some really big numbers. So we could put in 20, we could put in 55, we could put in 888, we could put in 9999. What's it approaching? It's approaching 5. By the way, I think if we go over here, it's not actually 5. If we went up and to the right here so that you were on this one, you could eventually get it to say 5 just because the calculator has to round. It only goes out so many places. But in theory, it is approaching 5. Okay? All right. What did we do? Where did we find this Ask Auto button? Second window. Is that it? Or Zoom? Window, isn't it? And when we turned it on Ask Auto, then we had to pick the X values. It's not going to generate a table of values automatically. But I didn't want to have to scroll down to 9999. Do you get what I'm saying? Okay. So we found out that it gets closer to 5 on the left and the right. How do we write that?
As X,
Yep, go ahead. As X approaches
infinity, it will, F X approaches 5.
and
As X approaches negative, it approaches 5. F X.
so this one was the right and the left. Both were approaching a Y value of 5. Everybody got it? Yep. It doesn't matter. Yeah, if you have values already in there, I don't know how to clean it out. You just type over the X's. Okay? If you hit delete, it'll clear them out one at a time.
I think
Yeah.
you go to the.
Okay. Yeah, it's different because it's in Ask Auto. You can delete them one at a time, I think, but that's about it. Okay. Use the graph to describe its end behavior. Okay. Guys, even if I gave you that equation, would you know it was a parabola opening up? That's all we really care about. It's both ends are going up. So y is approaching, or f of x is approaching what? As? Okay, infinity as x goes to infinity, and f of x is still going to infinity when x is going, what's the word for this one? Which is left. I should have said what's the direction, yeah. What's the word? It's a word. They're all words. Okay. This is back to a different question, guys. It's a yes or no. Is it continuous at -4? Do we have to graph it to find out? No, because when I put a -4 in, I get -6 over 0, undefined, so it is discontinuous. Or it's just no, it's not continuous. It's a yes-no question on the quiz, so. Pretty good? By the way, would it be continuous at 2? If you put a positive 2 in, you'd have 0 over 6. Is that okay? No, only one of them's undefined. Which one's undefined? When it's the 0 is underneath, it's undefined. 6 divided. If I have 0 pizzas, I can split it easily among 6 people. You all get nothing. So this is okay. Yes, it's continuous at 2. All right. Number 7. Is this graph, what does that look like? Do you know what a cubic looks like? Yeah, it's one of these guys. But it, other than the fact that my graph looks like it comes back on itself, it is a continuous function, right? So is it continuous at 1? Yep, that's continuous everywhere. Because remember, the restrictions are when the denominator equals 0 or a radical underneath there, right? All right, what about this dude? I think we should factor the bottom. What do you think? X plus 2, x plus 1. Now, before we divide anything out, the question says, is it continuous at -1? No, you'd actually get 0 over 0. Does anybody remember what that means? It's a whole. So it is, this is no, it's not continuous. And it would actually be a removable discontinuity, it's called. I'll just write whole. But it's just no. If you put a -1 in, you'd get 0 over 1 times 0, which would be 0 over 0. And anytime there's a 0 underneath, it's undefined. You good?
Yeah. I was just thinking that 0 divided by 0 is not 1.
Okay, this is why it's not. The rule is like 6 divided by 3 has to equal 2. It has to check when I do 2 times 3, I get back to 6. Is 0 times 1 back to 0? Yes. That wasn't helpful at all, huh, Power? Thank you for that method of proving that it doesn't work. Yes, that was genius. Let me rewind the video a little bit. You can't divide by 0. It's undefined. I'm moving on now. I'm going to have a video for you tomorrow on why that's true. It's not going to be me, obviously, explaining it. Okay. Determine between which consecutive integers the real zeros of each function are located on the given interval. So we're supposed to check the table from -6 to 2 and see where it changes sign. But we're not going to bother because we're just going to find it says, then find the actual zeros using the graphing calculator. Nearest thousandth means how many places? Tenths, hundredths, thousandths. 3 decimals, right? Okay, so we're going to graph this bad boy quickly. Y equals thank you. I'm terrible at that. X to the third, arrow to the right. Okay. Plus 5x squared minus 4. Thank you. I'm just going to try a zoom standard or zoom 6. Now, this is not a perfect window because I can't really see what's going on up here, but can I at least see the zeros? Okay. I want you to estimate where they're between because that's going to help us with our left and right. This one is somewhere between negative what? 6 and -4. Looks like there's one. There's another one between -2 and 0. And I'm stating those left to right because that's going to help us in a minute. And there's another one between 0 and 2. Now, we could get a little closer to those if we looked at the table. But remember, our table isn't turned on right now. So we're just going to find them. Do you remember how to find them? Second, trace, choose 0, choice 2. Now this is where what we just did will be helpful. There was one somewhere between -6, that's my left bound, just, what did I type? I didn't put a number in. I just put a negative. -6, enter. And my right bound was -4, enter. I don't care about a guess. So notice this is basically 0, right guys? Don't be fooled. So we're going to round this to 3 places, -4.828. By the way, if I trace and go -4.828, is it going to come out exactly 0? No, because we rounded, but it's closer. Close anyway. So write that one down. What was it? -4.828. Where's there another one? Can you find the other two, guys, quickly? Second trace between -3 and 0. I don't know. Yep. Close enough. Whoa. Uh-oh. I didn't even have the right thing going. Oh, my goodness. Number 2. Left bound. -2, 0. Make sure it's not on guess. So I got, it's exactly -1, yes? And then 0 is choice 2, and it's somewhere between 0 and 2. Make sure it doesn't still say guess. 0.828? Okay. I already forgot. -1 and 0.828. Did I get them all? Okay. So that's what you have to do on your homework. It says between which consecutive integers. No. Just go ahead and find them. Deal? That's why there's stars by 17 and 21 up on the assignment. It's because you don't have to follow the directions. Just go ahead and find the 3 zeros.
What's the point of the last number?
This was telling us that there are, you should find them between those, so that would help you with the window maybe if you wanted.
Okay.
Or if it had more, you could find them. I'm going to say we're good with this. Yes? Do we need to do another one on the calculator? Finding the zeros? There should be up to 4, right? Could be up to 4. All right, I'm going to talk about 11 real quick. Ohm's law gives the relationship between resistance, voltage, and current as the resistance is equal to the voltage divided by the current. If the voltage were to remain constant, so this stays constant, but we were to, current keeps increasing. If we were to increase this infinitely, what would happen to the resistance? Anybody get what they're getting at here? If the top stays constant, I'm going to pick 7. Seems like a lucky number today. And the bottom were to increase, like it were to get really, really, really big. Yes, the resistance would get really tiny. Yes, because this is approaching what? This graph approaches 0. Okay, the resistance would get tiny or approach 0. It would decrease infinitely towards 0. All right. Use the graph at the right to describe the end behavior. Support your answer numerically. I want to do this one on my calculator because I want to see if we can type that correctly. How should I type that? There's a... So what do I put first? Parenthesis. And then the top. 5x squared plus 6. Close parenthesis. Then what? Divided by parenthesis. Is it x squared minus 1? Is that what I saw there? close parenthesis. Do we need another parenthesis around everything? We really don't, because it would divide always before it added that 2 anyway, right? Yeah, if you wanted extra parenthesis, you would put one around the very front out here. You could put an extra parenthesis there, and then you would end before the +2 here and put an extra parenthesis there. You could certainly do that. All right, I'm going to do a zoom 6 and see what it looks like. If all we care about is the end behavior, it's definitely getting flat out on the ends, so this window is fine. What could we do to quickly determine what it's approaching? Do you remember? If I have it turned on Ask Auto, I can go to the table and put in some really big numbers. Now, if you want to delete all these ones we put in before, you can. But I want to put in some big numbers anyway. What's it getting close to on the right? 7. If I do negative, I don't know, I'm going to pick 4444 this time. Doesn't matter. It's a very negative number. It's approaching 7. So both ends are approaching 7. How do I write that in interval, or in f of x is approaching what? 7 as, how do I say the right side? X approaches infinity, and f of x is approaching what on the left? Still 7, right, for the y value, as x approaches negative infinity. Now, support numerically, that's what we did when we went to the table, okay? Eventually, we're going to learn, do you remember equal leading coefficient? Equal weight. It's not top heavy or bottom heavy. Remember that business? This is going to divide out, and we're just going to have the 5, and then there was a +2 on the back. That was, it was approaching 7. But that's a whole nother ballgame. All right. So I want you to look up here and see if you can pick which one of these would be the right answer. SAT kind of question. Probably actually not, because they don't use limits on the SAT. But this one's using limit notation. Which we didn't really talk about. But this is saying x is approaching negative infinity and positive infinity, negative infinity, positive infinity, negative infinity, positive infinity. So all of the values are there for x correctly. What do we want the y's to be doing? Both ends are pointing up. So we want the f of x to both be positive? Yeah. All right. So this is your, go ahead. It's hard to read. This is your homework tonight, and it is posted in Google. I will make sure that the bookwork is pulled up there. If you want to get started, what is the first problem? Number 3. It looks like this. It asks, is this continuous? Oh, that's a great question for a quiz. Does this one work at -6? No, because it would make the denominator 0. But does it work at +6? Yes. So this is no, it's not continuous, and then yes, it is. The next book problem is this one. What are we going to do here? Yes, if I put a -6 up here, I think I get -25. If I put a -6 down here, I get 8. So no, it's not continuous. It has a gap. No. Write them down. 17 and 21.